Hello, this is the Oceanite's CAD design for our CubeSat. As you can see, we have a pretty strange design compared to other groups, as when I was making this, I did not know how it was supposed to look like, so I just put it together in whatever way I thought made the most sense. In doing so, I decided to position the panels with the holes closest to the Type-C charging port on the Raspberry Pi, as I thought that's where most of the cables would be routed. As you can see, our design has the Raspberry Pi in the center and the camera right underneath it with the IMU right over here. On top we have the solar panel, and underneath that we have mounted the USB breakout board. What's not shown here is the power bank, which is supposed to mount to this panel with a piece of Velcro. However, because we have to put it inside the CubeSat, we decided to ditch the solar panel as it wasn't being used since we were inside, and mount the battery bank on the bottom of this panel inside. However, because the Velcro wasn't strong enough to hold it, it would often fall on top of our Raspberry Pi, which was not good. So in the end, we decided just to mount it on top of this panel here.
The software systems are easily the most involved part of the CubeSat project. The numerous demands of the project require a decent understanding of Python to fulfill. Two main aspects of the software are the navigational and imaging systems. This file contains both of the basic functions for these areas, while the second, Take Many Pictures Pi file actually executes them. It's taken in steps in which, after a certain amount of time, the CubeSat will automatically take a picture, name it, and save it for it to be uploaded through Bluetooth to the ground station file, in which it can successfully receive files and then upload them to GitHub.
Alright, so for our flight day results, we were able to get real-time images from one of our team members and post-flight images from two of our team members. And we were able to get the areas and sector locations of the guano and report those back to our TA, both during and post-flight. One of the big issues we faced as a team was getting the Bluetooth connection to work between our CubeSat and the ground station, and seamlessly send photos down to the ground station. One of our team members was unable to connect their ground station to Wi-Fi, which caused a lot of issues in terms of installations and getting the images to GitHub. For both of these issues, our solution was to simply upload the images post-flight and then get the location and area data. Lastly, one of our team members' cameras was not working, so they were unable to get any kind of images or data during the 10 orbits.